Okay, welcome back to Hand Tool Rescue. So this is part 3 of a 4-part massive chainsaw series. I have the finished chainsaw in front of me, and I'm really excited to get this whole thing wrapped up. So with this one, other than my genius wrench fitting exquisitely into the half-inch socket, this video focuses on the power head itself, since I've already done the carburetor and the bar and chain in previous videos. So the first thing I do with basically any fuel-powered tool is I check to see if it has spark. And I'm also checking to see if the piston is seized, and that was the first thing I did by pulling the rope. So this one, I was worried it wasn't going to spark, and then magically it did, which means that the points are probably fine, and most importantly, the capacitor or the condenser is fine. So that gives me hope. The condenser or capacitor is easily replaced. The points are not as easily replaced. So I am glad to see the spark. It makes my life much, much easier. These plastic caps are for the oil, the chain oil, and the gasoline, and both of them need some work since chunks are missing out of them. I don't really know how chunks get cut up off the caps, but whatever. That's the way it is. So I am trying to figure out here how I get this top part of the gas tank off, because I can see inside and I need to get inside to do some work, and I really don't understand why this is going on. And later on in the video you can kind of see the actual really tough glue that they use to glue that on, which makes sense. You wouldn't want any leaks anyways. A number of the bolts had these weird, I don't even know if you can call them washers, but they are just flat pieces of steel in random shapes in some cases. You'll see more of it, and I guess that's what they use to make sure it doesn't unthread itself. Since most of these old saws don't have any anti-vibration technology, they will vibrate apart, so that's I'm assuming what McCullough did to kind of mitigate that is to add these weird pieces of steel. If, I had to redo this and didn't kind of stick to original, I would probably just use lock nuts on almost everything here, just because it's going to vibrate itself to pieces. So we'll see how long this lasts once I put it back together and try to cut some wood. The main castings are all magnesium based alloys, except for some of the handle parts, which are just aluminum. So you just have to take your time and go easy on these things, because they're not very strong in the sense that they're very brittle. Here I'm trying to figure out how to remove the actual power head from this handle frame. It seems to be caught on a bunch of stuff, and it actually took unnecessarily long to figure it out, since there's all these weird bolts and things that need to come out first, which only makes reassembling more complicated, since there seems to be a specific order you need to disassemble or reassemble the saw in. So this is me kind of just taking shots at the dark and taking off what I can visually see. And here I'm taking off the muffler, which of course you can see me restore in a previous video. I just have to tell you that the new muffler sounds fantastic. So the throttle, which you can see here, that says throttle, is interesting because not only is it just cast aluminum, but it's the same piece as the oiler. It's literally the exact same casting, so they kind of did that, I'm assuming, to make some sort of discounted item. It's just cheaper to produce one cast piece and flip it over, and then not have to worry about casting separate pieces. And you can see here where it says chain oiler and where it says throttle, it's literally the same thing. And I ended up using this to my advantage when I pieced the saw back together because I like to switch things around to kind of my personal use. And here you can see the bottom of the oiler side, which obviously says throttle, because it's that same part. The oiler seemed fine in terms of how it pumps and how the handle works. So I was glad that that didn't need work, because if that needed work, it basically would be a full replacement, and I'd have to find that part, and that's not a very common part at all. None of the parts in this saw are very common, which makes this restoration much more stressful than most, because I really don't have, the money to recreate all the parts that would be needed, since these parts are rare. Now that I've taken a bunch of stuff off, I'm pretty sure I can hammer out the main power head off of this frame, and just using a soft rubber mallet to kind of tap it in. But of course, there's some tab for some reason. I still don't know what it's there for or why it was designed that way, but regardless, the transmission, as it's called in the manual, needs to be removed, and this kind of clamp, ring clamp, needs to be fully disassembled before I can get that off, apparently. Now I can actually get the saw out of the frame. It only took, off camera hours to get to this point, because I need to keep track of things and make sure I'm not breaking anything. So it's just nice to finally have it apart so that I can get to the real focus of this specific video. This is the magneto. This provides the spark as the magnets, as you can see on the flywheel, which are just attached at the bottom of the magneto, pass through the coil and create a current, which then sparks the lovely spark plug. I always kind of put small screws back into their respective holes, just because I know I'm going to lose them, and there's no point in stressing myself out with that kind of thing. This needs to be okay, which, since we do have some spark, it's probably okay. It's when I cleaned it up, it looked nice, and I could actually measure the actual kind of voltage coming off that, but I don't have any reference point. I don't know what it's supposed to be. All I can do is just compare if it has spark or it doesn't have spark. So that's kind of the test I'm going to do in this case. With modern saws, you have all these specifications that you can follow. This is the flywheel and puller attachment, I guess, if you want to call it. I'm just trying to get the flywheel off. I don't know if it's ever been off, but based on how stuck on it was, even with the flywheel puller, it was aggressive. I thought I was going to break something. It was just insanely stuck on there. For a tapered fit, it's surprising that it wouldn't just come off more easily. You don't want to lose these. My God, you don't want to lose those. So please, if you're taking apart something like this, do not leave the keys, the little tiny Woodruff keys, somewhere. Just let them be. This is fantastic wiring going on here. Nice aluminum wire from back in the 50s. And it has disintegrated. It's a very odd placement for that. I don't know why they would put it there, but that's a lot of... I end up saying that a lot as I went through this chainsaw. Like, why design it this specific way? Considering this is kind of like a second model, the ones before it, which were model 549 and I think 749 or something, were built similarly, so they just kind of went with that and stuck with it. These the gears, they're very, very nice, like extremely nice condition. I am very surprised at this, considering all that hole kind of at the bottom there is the only thing that provides lubrication. It's just, the gas oil mix that provides the lubrication there. So I didn't see anywhere in the manual where I needed to grease these or oil these. As much as it pains me not to do that, I'm just going to leave it as I found it, and it will be lubricated enough for at least testing purposes. This right here is the actual oil pump that I was talking about earlier. And you can see when I pull it out, it's in great condition. Usually stuff that's oil related is in fantastic condition. All it needs is just, replace some O-rings and call it a day on that one, which is nice. Here's another example of just weird metal washer things. You need to kind of tap and hammer them out. Some of them are just like they were like cut with a torch. It was like really weird edges on a lot of them. Here's the carburetor, which once again is in a previous video. It was so unnecessarily complicated that decided to give it its own video. So once that's removed, we finally get to the crankcase and cylinder head. I'm hoping to get in and disassemble everything I possibly can to make sure that when I put this all back together, it's not going to explode or get ruined. Here's some delicious corn. I guess a mouse or something must be storing it in here, or they're cutting things in a cornfield. I don't really know the last 75-year life of this specific saw, but it's always interesting what you find in old tools. Finally take this carburetor out and focus on the gas tank itself. I decided, since I can't seem to get the top off, let's have a look inside. And it was actually fairly corroded. Maybe not fairly, I guess lightly corroded. Which means, in terms of magnesium, was probably some sort of acid or acidic something was in the gas tank. Because the oil side is fantastic and it looks pristine. Right here, you should be able to see the glue line once I stabilize. And that's the glue line holding the tank together. So at least I know now it's not like a mechanical, like they welded it or brazed it on or something. I can probably peel it away. And then I'm checking the cylinder, just check if it's scored, if there's straight lines on the side that are more aggressive. These are just oil lines, but if there are aggressive scratch marks vertically, it's probably toast, and that I would need to either machine a whole new cylinder or sleeve it, or do something like that to get it back to what I need to. Luckily, not the case for this specific saw. Here we have the points and the condenser. So, the condenser is the big cylindrical thing, and the points are just below kind of where the black wire comes out of the cylinder. And then the condenser and the points are attached to both the magneto and the on-off switch on the chainsaw itself. Once I got this off, you can kind of see all the conditions of the different rubber grommets, which were actually a little more difficult to find than I thought it would, but for whatever reason, I guess they used some sort of specific sizes for this specific saw. Obviously, I won't be reusing these wires, so I can just cut those and use those for reference later. And the same with this jumble of wires here. And I kind of understand why they're in such poor condition, because the method that these were attached, literally they come out of the points and condenser, and that's it. They go straight into the air, wires flopping around all the way to the power switch. So they're going to get damaged over time. Not a smart design. They could have ran the wire through the handle, and I was tempted to kind of do that, but I didn't want to mess with the saw and drill holes in places that don't belong. So this is the actual points right here. I'm going to save these for later. I'll sand in between the points just to clean them up so we get a better electrical connection. And those will be done. There's no rust. There's no issues. Very happy with the condition of that. As bad as the saw looks like on the outside, the inside has been fantastic so far. So that is a great sign. I don't know if someone took care of this in a proper way, or just the design of the internals is nice. This is one of the push rods that transfers the movement of the flywheel to the points so they open and close as the flywheel turns, and you'll see me demonstrate that when I put it back together, in case you want to see that. I always love using little old earplugs to block holes, especially when painting. They're just handy and they're cheap, so it's a good tool if you have one. What isn't a good tool is this crappy Allen key. Just don't buy discount Allen keys. Just spend $10 more and get real, actual hardened Allen keys, because these bolts were very tight and they're probably torqued to some specification, which I'll never know. But regardless, buy real Allen keys, people. So the cylinder head is off, and you can see some light carbon buildup, but you can see how we have a blown head gasket with all that black carbon buildup on the right side. That's where exhaust or whatever has been exploding out the side, so I will have to address that when I piece this together. And now the clutch. So this thing is my arch nemesis. I know it's reverse threaded, so that's why I'm turning it this way. For a moment, I thought it wasn't, so I did everything that I've done here in the reverse direction, but it just kept on fighting me. So the first thing to do would be to put a piece of wood in the exhaust port and to block the cylinder from moving. It's an adequate way. It's not, the best way. It's not the most risk-free way. The problem is the more pressure I put on this, the more the cylinder just literally cut the piece of wood right off and in two pieces. So clearly I needed more force or a stronger item to put into the exhaust port, since nothing was working. It was very, very frustrating. So let's try heat off camera. I tried a bunch of other things, including wax and acids and different types of leverage. It's just an insanely annoying procedure. Here I'm using a piece of Jatoba, which is very hard. The long grain, so it doesn't just shear off easily. And I'm assuming this would work just fine, but no, I am a failure. I am a garbage human being. I cannot be done. Not to mention I don't really have the right tool. Like, this is the timing belt adapter or something. I forget what this tool is that I'm using. I just kind of custom ground it to fit. Another trick that I tried was to stuff a rope in there so the cylinder or the piston doesn't move up and it can stay blocked and locked, so I can try to spin that clutch off, because if I can't get the clutch off, I can't get into the crankcase really, and I can't take a bunch of things apart. And there are seals, there are oil seals like the crank seal behind the clutch that may or may not be worn. I didn't notice anything that would indicate that it's worn, so I would hope that it's fine, but you just don't know until you have a look, and that's what I really want to do here. So even listening to Nickelback didn't get the clutch to move. It's very annoying, and yes, I can put more leverage, I can get an impact, I can do a bunch of other things, but the limiting factor here is the fact that this thin magnesium housing is taking all the force of me pushing on the clutch to kind of spin it out, and eventually it would break. It's very thin. It's not even an eighth of an inch thick in some cases, and it would just literally break. So I can't risk it. It's not worth it. Welding magnesium alloys is not fun. So I got to leave the clutch on, unfortunately. So that means that to get to the crankcase, I got to take the cylinder head off. And here you can see the piston itself, which isn't scored. And, once I clean up with a cloth, it looks totally fine. There aren't giant black lines and grooves cut into it. So that's great to see. Once again, that sign that it was adequately lubricated. It was probably too lubricated. That's why you have all that carbon buildup. It probably ran with either too much oil or with too much gas. but it's fine. Not the end of the world. And once you got the piston off, I wanted to make sure that the wrist pin itself, the pin that attaches the cylinder to that shaft right there, didn't have any play in it, wasn't worn, because if I could move the cylinder around and there was play, that was something that would have to be addressed. But luckily I do not, and it was great. I decided to have a look with a little kind of periscope camera that a viewer, James, sent me, which is awesome. And it let me have a look at parts of the crank inside the crankcase that I wanted to make sure weren't damaged or had any major issues in any way. And these are just oil marks. I was able to get them off by just scratching it with my finger and wiping it with some brake clean and stuff. So the internals actually look fantastic. There's no crazy rust, as you can see. There's no rust, period. It's actually really, really nice in there. So that made me more confident in not being able to remove the clutch and the timing gears on the other side and just leaving the clean internals. There's no point in messing with it. I might mess with the timing and throw the whole chainsaw off and it'll never run. So just leave it. Don't fix something till it breaks. There's no point in stressing yourself out. Here I'm finally just showing all the parts that had the wire wheel. These are all just brass wire wheels on the soft magnesium, so it was fine. And it comes out with a nice kind of brushed look that I particularly liked. It's not super shiny or anything. It's just what makes more sense for something like a chainsaw, I would think. This is a McCulloch 35. Same kind of vintage. And it has the proper McCulloch Goose medallion that is so sought after. These are often gone because people just rip them off since they're collectible. So I will use this for the missing medallion on the pull start. I could get it CNC made, but that's going to be $1 billion. Here's the cool fingerprint of the previous painter, which I thought was really neat. I really want to keep that, so I'm not going to, remove that with paint stripper. I'm going to keep the little fingerprint there. I think it's neat. So this is where the medallion would actually go on the other side, the side currently right there. That circular opening is where there should be a medallion. So I will paint that and fix it up, and it'll be fine. You gotta taste the chainsaw oil / sawdust mixture. It's just delicious. So now we gotta have a look at the pull start. Like I know it works in terms of when I pull it, it springs back. But I just absolutely hate opening these up and cleaning them because the spring explodes in your face. You risk breaking the spring. Who knows what's going on? You risk dying by having springs explode and trying to murder you. So I'm not into that at all. It's just something I just absolutely hate. So I'll clean this just with an insane amount of brake cleaner. Get every possible piece. I'll soak it in some high-strength detergent and just get it actually clean on the inside and out without actually having to take it apart. It's not the end of the world. I personally don't care because it's more of a risk that it springs open and another part that's really rare that I have to go find would have to be found, and it's just not worth it. So might as well do it like they do at the factory for this saw and paint it fully assembled. Not crazy fully, but I'll just put the two pieces back on, paint over any areas that need paint, and tape where we got to tape. It does have a kind of gash you can see on the left side of the pull start, so I'll fill it with this metal infused body filler. It seems to work pretty well for these types of alloys. It sticks adequately, and it sticks better than Bondo, at least I think. it's just more of a cosmetic thing at this point, but these gashes are so massive that, you know, I can't just leave that without addressing this. Once again, the paint stripper here, so you can kind of see as I'm cleaning it up that there's paint that comes off really easy, and then the underlying layer, which I believe is the primer at this point, is also yellow. So there's just 2 coats of paint. It's not, you know, magical. And you can see once again here how they just painted it fully assembled with parts that have paint and parts that don't. But you know, you need to get into this, and that's what I'm going to be doing here. I gotta crack this tank open. It needs to be done. I am going to take this off. I could use a heat gun, but I don't want to get too hot with a gas tank. So I'm just going to peel it off with a razor blade. I'm not going to bend the aluminum in any way. I'm going to be gentle. And that'll be it. I will find a replacement or remake this if I can to get it looking as amazing as humanly possible. Here's where a bunch of people will get mad at me for using chisels like this, but what else am I supposed to use? It's literally the perfect tool. These are my shit chisels, so I don't care. Everyone on Earth has one of these, so it's fantastic, and it works exquisitely. Give it a try. I don't really know what this kind of adhesive was. It's kind of papery. But as long as it's all removed, I can put something underneath that. That'll be just fine for glue. So I get one corner at a time. I try to tap a razor blade into each corner to kind of just start breaking up that glue. I don't know if it's hard glue. I don't know if it's like sticky, always super sticky glue. I have no idea what, you know, they were using in 1954. When they made this, but I was able to crack it up, and you can see the glue is very stringy, very sticky, very elastic. So getting this apart would have never worked with a hammer. You need kind of like a constant force. And then you can finally see the situation in this gas tank. So the top is obviously fine, but the bottom looks a little poopy. So I will have to address that. Luckily, the filter at the bottom is nice and clean. Here I am. I'm trying to save this logo the best I can because it's in, you know, it would be nice to kind of save it. But as I put the painter's tape down, I noticed a corner kind of rolling up, and then I just lifted it up, and it was just great sadness. So I failed big time on that one. This will just have to be recreated, and that has been done. I took photos beforehand, of course. I didn't have to do it by memory or any insane thing like that. So I'll just have to remake the sticker and call it a day. Even though this is not original from the factory, it's original from the dealer. And I think it's just interesting because they're still in business, which is awesome. Now, I finally have all the parts cleaned up, which took an extremely long time because it's lead paint and I can't just use, you know, like a wire wheel and sandblast stuff. So I just went with my usual, you have to use self-etching primer on magnesium parts, and went with 3 coats of yellow enamel. It seemed to closely match, which was fantastic, to the original yellow. And then a nice red for the original medallion. And that's more than adequate to get the kind of colors that I want out of this. McCullough with the yellow changed a lot through each batch. So there's just, you don't need to worry too much with doing McCullough saws. They all look oddly different with different yellows. It's frustrating. What can you do? These are the gas and oil caps that need work. You can kind of see the damage more clearly now that these have been cleaned up and disassembled. I'm using this plastic weld or Plasta-Weld. I've used it before, and it's fine. It doesn't harden very hard. When it dries, it's not fantastic, but it is adequate for this purpose, so I'm just going to go with that. This is, once again, the 2K paint. It's completely fuel resistant, maybe even fuel proof, although I don't know what's fuel proof. And I can confirm this now that I spilled gas all over the finished chainsaw. It is totally fine. It just wiped right off, and even hours later, it didn't do anything to the paint. So I'm really happy with this paint. And I went heavy on it. I used at least 3 coats of this clear coat on all parts. I don't want to risk anything, and the reason I have to do this is because I can't get the clutch off. Otherwise, I would have powder coated this whole chainsaw, which I really, really wanted to do because I haven't done it, and I think it would be a perfect finish for a chainsaw. What can you do? Maybe next time on the next chainsaw. So I look forward to seeing you all in the final episode. It's going to be exciting, I hope. Later.